Okay, today we're going to do a quick review of the algebra for solving systems of equations. Now, if you remember having a system of equations is when you have more than one variable and you have more than one equation, and you actually need at least the same number of equations that you do variables in order to solve for all the variables. So in this case, we have a system of equations that has both x and y. And in order to find solutions for x and y, we need at least two different equations in order to solve for both x and y. You've probably talked about lots and lots of different ways that you can solve systems of equations like this. The first one is called guess and check. And guess and check is when you make simply a guess, a wild guess for what x might be and y might be. And then you go through and you calculate, does this first equation come out true with those guesses? And does the second equation come out true as well? And if both equations come out true for your guess, then you found your answer. It's not the most fun way of solving for systems of equations. And so a lot of students kind of give up. They don't really like their system of equations to be solved by guess and check because it can take a really long time unless you figure out how to be really good at guessing at them. Another way that you can solve systems of equations is to graph them. If you remember correctly, if you remember your algebra, you know that each of these equations has to graph a straight line. And so in order to graph your solution, you would want to find the point at which these lines cross. And that intersection point will be the solution for the system of equations. Now, the graphing method helps quite a bit. It's certainly faster and more methodic than guess and check, but sometimes it's hard to get an exact answer from the graph because we don't always graph very carefully or very precisely on our paper so that we can come up with exactly that right answer, especially if the true answer is a fraction or a decimal of some sort. It can be really difficult to come up with exactly the right answer if you're using the graph method. But the two methods we're going to talk about today are substitution and elimination. Substitution and elimination are the most tried and true methods that most algebra students remember when they're going to solve a system of equations. The first one we're going to talk about is elimination. So for elimination, the first thing that we would do with this problem or with this system of equations is to notice that we have a 3y here and a negative 3y there. So if I were to add these together, what would I get if I had 3y plus negative 3y? Hopefully you said 0. 3y plus negative 3y is 0. So if I add these things on the left, I will get 4x plus x, which is 5x, plus 0, which I wouldn't need to write down, equals a 35. Right? So again, we get 4x plus x is 5x. This is going to be 0, so we don't need to write anything in this spot right here. And 34 plus 1 is a 35. So now we have 5x equals 35. And the next thing to do to solve for x is to divide both sides by 5 so that we get x by itself. So again, we divide both sides by 5 because if we divide one side by a number, we have to divide the other side by the same number. And then we get x equals 7. Great. We've found our solution, but we're still not done because remember, if we're doing a system of equations, we actually need to find answers for both x and y. So the next thing we do is we take this value for x, we substitute it back in for one of our equations in the x spot because that's what x is, and we find what y has to be. So the second equation was x minus 3y. Instead of an x, I can write a 7, substitute that 7 in. 7 minus 3y equals 1. Subtract 7 from both sides. Negative 3y equals negative 6. And then again, to get y by itself, we're going to divide both sides by a negative 3. And we get y equals a 2. Great. So our final answer ends up being x equals 7 and y equals 2. And since we have x and y, we can put it in an ordered pair notation because x always comes first. And we have our solution. That's how we solve it with elimination. Now, if I went through it a little bit too fast, you're welcome to pause the video, go back and listen to it again and see if it makes more sense. Okay? Another way we can solve the same system of equations is to use the method called substitution. Now for substitution, we actually want to start by getting one of the variables alone. We want to isolate one of the variables. If we look at the top equation, to get x by itself, first we'd have to subtract 3y from both sides, and then we'd have to do another step of dividing by a 4 on both sides to get the x by itself. But in the bottom equation, it's a little different, because once we add a 3y to both sides, x will already be by itself. We don't need to do the second step. So let's do that. We're going to add 3y, and then x, this will be 0, equals 1 plus 3y. Okay? And x is already by itself. We don't have to do another step. So that's awesome. Now we have one equation where the variable is all by itself. So let's jump to the other equation. We have that 4x plus 3y equals 34. So now instead of an x down here, we can substitute something else because we already know what x is equal to. Instead of having an x in this position, we can also write 1 plus 3y. So we'll have 4 times 1 plus 3y, because that 1 plus 3y is the same as x. It's just going to take the position of the x. So 4 times 1 plus 3y plus 3y, that's this 3y comes over here, equals 34. The next step is the distribution property. So now since 4 is being multiplied by all of this stuff in parentheses, we have to distribute the 4 through the parentheses. So we have 4 plus 12y plus 3y equals 34. Add like terms. 4 plus 15y equals 34. Get y by itself. We're going to subtract 4 from both sides. 15y equals 30. Y is not by itself yet, so now we'll divide by 15. Y equals 2. Okay. Again, we still have to find x. So we're going to substitute this y up in this spot. So x is equal to 1 plus 3 times y, but y we know is 2, so that's 1 plus 3 times 2. 1 plus 6, x is equal to 7. So now we found an answer of 7, 2, which is exactly the same thing that we found when we found the solution through elimination. So it doesn't matter which method you choose to solve the system, you should get the same answer. Let's do one more example of a system of equations. So let's start with 3x plus 7y equals 25. And our second equation will be 5x plus 4y equals 11. Now, a lot of times students will look at the two problems, or the two different methods that we did to solve the last problem, and they'll say, well, I really like that elimination way. It was a lot faster. So let's see how we can use elimination to solve this this system of equations. When we look at it, however, we don't have a 3 and a minus 3. We've got a 3 and a 5x. So if I added those together, I'd have 8x, not 0. That's not a good sign. And when I look at y's, I find something similar. If I add 7y plus 4y, I don't get 0y. So how could I solve this? Well, one of the easiest ways to get this to elimination is to multiply the top equation by the number in the coefficient of the x term in the bottom. So I'm going to multiply the top equation by 5. And I'm going to multiply the bottom equation by a negative 3. Why would I make it a negative 3? Multiply the top equation by 5. So then when I multiply that through, I'm going to get 15x plus 35y equals 125, because 5 times 3 is 15. 5 times 7 is 35. And 5 times 25 is 125. Now what happens on the bottom is I multiply the 3 times a 5 and I get 15x again. But I really don't want 15x here. I want to be able to take 15x plus whatever this number is and get 0. But 15x plus 15x is 30. It's not 0. So that's why I multiplied the bottom one by a negative 3, because negative 3 times 5, that's not a decimal place, by the way, negative 3 times 5 is a negative 15x. So now when I add those together, I'll get a 0. Negative 3 times 4 is negative 12y, and negative 3 times 11 is a negative 33. Now I can add my equations together. 15x minus 15x is 0, which we don't need to write down. 35y minus 12y is 23y. And 125 minus 33 is 92, right? Y is still not by itself, so we divide by 23, divide by 23. Y is equal to 4. 92 divided by 23 is 4. Again, we're not finished. We still have to solve for our x because we've only got y. So 3x plus 7 times y, well, y is 4, so 7 times 4 is equal to 25. 3x plus 28 equals 25. 3x, subtract 28, is equal to negative 3, and x is equal to a negative 1. So our ordered pair is negative 1, 4, and we found the solution. Now to check the solution, you would take this value for x and that value for y and put it back in here to see if you get 25, or put it back into the other one to see if you get 11. Okay? Go ahead and try your homework.